Hey guys, welcome back to my YouTube channel. For this video, I'm going to discuss about conic sections parabola whose vertex is at the origin. Our objectives for this discussion is to define a parabola and identify the properties of parabola whose center is at the origin. A parabola is the set of all points in a plane equidistant from a fixed point focus and a fixed line directrix. So this is the illustration of a parabola if a plane intersects on a right circular cone. First, let's define some terms in parabola. Vertex, the point midway between the focus and the directrix, or the midpoint of the shortest line segment from the focus to the directrix of the parabola. Focus is a fixed point. Directrix is a fixed line. The latus rectum is the chord of the parabola through the focus and perpendicular to this axis. Axis of symmetry is the line through the vertex and the focus of the parabola. So there are four equations if the vertex is at the origin. The first one is y squared equals 4ax. The table here shows the properties of this equation, and in the right side is its graph. So the vertex is 0, 0. The focus is at a0. So the value of our a is 1. So our focus is 1, 0. The directrix is the line x equals negative a. Just substitute the value of a, which is 1, so x equals negative 1. So if we locate the directrix of this equation, it located here, the broken line. Next is the axis of symmetry is x-axis, or the line y equals 0. The end point of latus rectum are a to a and a negative 2a. Substitute the value of a, which is 1, so the latus rectum are 1, 2, and 1, negative 2. And as you can see, the opening or the concavity of this graph open to the right. The second equation is y squared equals negative 4ax. So this table is the properties of this equation, and this one is its graph. So first let's locate the vertex. So the vertex is at 0, 0. The focus is at negative a, 0. So our value of a is 1. So let's substitute the value of 1 in negative a0, so our focus is negative 1, 0. So if we locate our focus is here. The directrix is the line x equals a. So substitute the value of a, which is 1. So our directrix is x equals 1. So the broken line here is our directrix. Axis of symmetry is x-axis, or the line equals 0. The ends of latus rectum are negative a to a and negative a, negative 2a. So again, just substitute the value of a, which is 1. So our ends of latus rectum is negative 1, 2, and negative 1, negative 2. And our opening, or the concavity of this graph, opens to the left. Our third equation is x squared equals 4ay. So the vertex is at 0, 0. The focus is at 0, a. Since the value of our a is 1, so our focus is 0, 1. The directrix is the line y equals negative a. So just substitute the value of a, which is 1. So our directrix is y equals -1. So the directrix is here, the broken line below the curve of the graph. The axis of symmetry is the x-axis, or the line x equals 0. The ends of latus rectum are -2a, a, and 2a, a. Substitute the value of the a, which is 1, so the latus rectum are -2, 1, and 2, 1. And the opening of this graph opens upward, like this. Lastly, the fourth equation, x squared equals -4ay. So the vertex is at 0, 0. The focus is at 0, -a. Just substitute the value of a, which is 1, so your focus is 0, -1. The directrix is the line y equals a. So our directrix is y equals 1 after substituting the value of a. So the directrix is located here, the broken line above the curve of the graph. The axis of symmetry is the y-axis. The ends of latus rectum are -2a, -a, and 2a, -a. Substitute the value of a, which is 1, so our latus rectum are -2, -1, and 2, -1. And as you can see in the graph, our opening opens downward. Let's have an example. Number 1, find the equation of the parabola with vertex at the origin and focus at 3, 0. So let's first find the distance from vertex to focus. If we plot the vertex and the focus in the graph, so it looks like this. So the value for a equals 3. Since the ordered pair of the focus is 3, 0 or a 0, so the equation that we're gonna use is the first equation, y squared equals 4ax. Substitute the value of a, which is 3, so the equation of the parabola is y squared equals 12x. And if we graph this, it will looks like this. The graph open to the right. Second example, given the parabola y squared plus 8x equals 0, find the directrix and the focus and sketch the graph. So the given is in the form y squared equals -4ax. Let's first find the value of a. So -4a equals -8 from the given, so a equals 2. Always remember that the value of a is always positive. So the ordered pair of the focus in this equation is -a, 0. So the focus is at -2, 0 with vertex at 0, 0. And the directrix is x equals 2. So this is the graph of y squared plus 8x equals 0. Exercise A. Find the equation of the parabola having its vertex at the origin and its focus are the following. Exercise B. Given the equation of the parabola, fill in the blanks. If you have any questions, clarification, and suggestions, kindly comment it down below.